Section 5.6, inverse of a function. We're going to learn about what an inverse is and how they work compared with our current idea of a function. Okay. So first, our objective is to explore inverses of functions, find and verify inverses of nonlinear functions, and then solve some real-life problems using these inverse functions. Okay, so first in this example, okay, we're going to start here with this function. We have the function f of x equals 2x plus 3. Okay, so what we're going to do is we're going to solve this function y equals f of x. We're going to solve this for x. Okay, so we're going to solve it for x. What that means is my end result is I want an equation down here at the bottom that's x equals something. Okay, so they tell us to set y equal to my function. So here's my function right here. And we're going to set y equal to that. So y equals to 2x plus 3. But now right now it's a y equals. We want to get it down to where it's an x equals. So we're going to solve this for x. So we're going to go ahead and let's subtract 3 from both sides. So we have y minus 3 equals 2x. And then we'll divide both sides by 2. So x equals y minus 3 all over 2. So my original equation was a y equals 2x plus 3. Now my new equation is an x equals y minus 3 all divided by 2. So the difference here is in this function, we input x, and then we get out y. So we put an x into this function and we get out our y. In this one, we're actually going to input our y value and we'll get out an x. So here for part B, if it says find the input when the output is 7, again, inputs are always your x's, outputs are always your y's. So basically, we want to find the x that gets me out a negative 7. So basically, if y equals negative 7, what does x equal? Okay, so when y equals negative 7, what does x equal? Well, that's where this equation comes in handy, because I know x equals y minus 3 divided by 2, so now I can just sub a y in. Negative 7 minus 3, negative 10 divided by 2, x then equals negative 5. Okay, so I know when I put in a negative 5 for my input, I'll get out a negative 7 back into this original equation. These two functions are examples of what we call inverse functions. Okay, meaning if I have my original function, which is a 2x plus 3, okay, then whatever I put into this, it's going to multiply it by 2 and add 3, and then give me something out. Okay, so if we think of this function as a machine, if I put in a 4, it's going to take the 4 times the 2, 4 times 8, and add 3. If I put in a 4, 2 times 4 is 8, plus 3 is 11. It'll get me out an 11. So we can put that in a table. When I put in a 4, it's going to give me out an 11. Okay, so we'll go ahead and put that in the table here. All right, when I put in a 0, 2 times 0 plus 3, so that would give me out a 3. When I put in a 1, 2 times 1 is 2, plus 3 is 5. When I put in a negative 1, 2 times negative 1 is negative 2, plus 3 is 1. Okay, so when I put in x, I get out y's. What an inverse does is an inverse does that opposite function. So basically, this here is our inverse function. Okay, but we're going to flip-flop my x's and y's. And how we write it is we'd write it as f. This is my f function, but it's the f inverse. We put a little 1 up here on the f. It's kind of like an exponent, but not really. We read this as f inverse of x would equal x minus 3 divided by 2. Okay. It still has that same idea. I still put stuff in. It still gives me stuff out. But now it's going to take x, subtract 3, and divide it by 2. Okay. So now what happens when I put in a 3? Let's put a 3 into this. 3 minus 3 is 0. Divided by 2 is 0. So I put in a 3. I get out a 0. What about when I put in a 5? 5 minus 3 is 2. 2 divided by 2 is 1. What about when I put in a 1? 1 minus 3 is -2. -2 divided by 2 is -1. What about when I put in an 11? 11 minus 3 is 8. 8 divided by 2 is 4. Okay, so these two functions are what we call inverse functions. I want you to go ahead and look at these two tables. Do you notice anything? Okay, if you notice, the point 0, 3 is a point on this graph, but the point 3, 0 is a point on this one. What happened to my columns? Here in my x column, I have a 4, 0, 1, -1. What about my y? 4, 0, 1, -1. Your x's become your y's, and your y's become your x's. So when an inverse function, over here, again, remember our domain is your x values, your range is your y values. Same with an inverse. My domain here is my x values, the range here is my y values. But if you notice, the domain for the function now became the range for the inverse. Okay? And the range for my function is now the domain on my inverse. The domain became the range, and the range became the domain. Okay? So let's look to see, and I always like to think of then these inverse functions, what the inverse does, what the function does to a number, the inverse undoes it. Okay, so here, this took 4, multiplied it by 2, and added 3. It got me out an 11. If I come and put this 11 into here, if I put an 11 into here, it's going to spit me out the 4, back to where I started. Okay, so basically, if we think about this as two machines, if this machine, if I throw in a piece of plastic in this machine and it makes it into a whistle, this here machine, would I throw the whistle in, it would get me back out the piece of plastic that I started with. Whatever this machine does to the number, this one undoes it. That's the whole gist of an inverse. So now let's look at the two graphs. Okay, so here I'm going to color code, so different colored pens might be useful here. I'm going to graph the function here by, I'm going to, well, this is y equals mx plus b. So I can tell here that this 3 is my y-intercept. 3 is my y-intercept, 1, 2, 3. And it's got a slope of 2. So 2 over 1. So rise of 2, run of 1. So my line's going to look like this. We also could plot these points here. I'll have the point 1, 5, which that's the point I have, -1, 1. I'd have the point 4, 11. I'm not going to graph that point. So my function, my original function looks like this. So this is my f of x function. Okay, that pink line right there. All right, so now I'm going to use blue. Let's graph this inverse function. So to graph this, I could rewrite this, divide these both by 2, so this would be 1/2 x minus 3/2 for me to find my mx and my b. I think I'm just going to plot some points and connect them, just because these are fractions and I don't want to deal with those right now. So we'll have here the point 3, 0, 1, 2, 3, 0, over 3 up 0, 5, 1, 1, 2, 3, 4, 5 up 1. And then we have 1, -1. So we can kind of see the line that this is creating. So this blue line here is my inverse, f inverse of x. Okay. So if you notice, they have a little bit of some, like, it just kind of flips it over. Okay. And so actually what an inverse does is an inverse reflects it. It's actually a reflection. It's a reflection over the line y equals x. And so the line y equals x, this is a line where all my x's and y's equal the same thing. So I have the point 1, 1, 2, 2, 3, 3. It's this dotted. It's this line right here. I'm going to draw it in dotted. So basically what an inverse does is an inverse will reflect it. So if I take this pink line and reflect it over this diagonal line, it will give me the blue, or its inverse. Okay. So inverses have that bit of a reflection. It's a reflection over the line y equals x. Okay, so now let's look at how to find the inverse. Let's go ahead and let's find the inverse of this simple-ish type function. I'm going to show this to you in two different ways. We're going to do it two different ways, so I'm going to color code that. Okay, first is I'm going to rewrite, let's not rewrite that yet. Okay, so I'm going to take this inverse, we're going to do it two different ways. The first way is using something called mapping. Basically what it is I would think of what does this function do to x? Okay, so what does this function do to x? Meaning when I put an x into this function, what's the first thing I do? If I'm substituting a number in, like let's say I was substituting a 5 in, what would I do to that number first? Well, we'd multiply it by 3. So I'm going to go ahead and I'm going to draw an arc. In this arc, I'm going to put it, okay, this is multiplying by 3. And it's going to give me something out. And what I get out, again, depends on what I put in. Okay, but I'm going to multiply by 3, and it's going to give me something out. And then once I'm done multiplying by 3, then what do? I subtract 1. So my next step is going to be subtracting 1. And then I get my final answer out. I get my final output, right? Okay. So first thing I do to x, okay, let's put a bubble here on x. I take the number I'm putting in, I multiply it by 3, and then I subtract 1. Okay, but for me to write the inverse, I'm trying to write f inverse of x. We need to go backwards. So I need to map this backwards. So if I'm starting now on this end instead, to go backwards from this to this, instead of subtracting 1, I'm going to need to add 1. And then once I'm done adding 1, I'll need to divide by 3. Divide by 3. So now, instead of me starting here, I'm going to start over here. So I need to take my x and add 1. And then after I'm done adding 1, what do I do to it? I divide that whole thing by 3. So then I need to take the whole thing and divide it by 3. So there's my inverse. I would take my x and add 1 first. So I take my x and add 1 first, and then I take that and divide it by 3, and that's going to get me my inverse. Okay, so this is the mapping method. Hey, we think, what do we do to x first? We multiply it by the 3. Basically, it kind of just relies on using that order of operations. And when we're undoing it, we have to undo it backwards. Okay, so when you're writing the inverse, you have to undo in a backwards order. It's kind of like putting your socks and shoes on. First you have to put on your socks, then you put on your shoes. But to undo it, you have to do it backwards. Take off the shoes, take off the socks. Okay. Okay, so that's one method, that's using the mapping method. Okay, the other way is using this idea that domain becomes range and range becomes domain. So basically how we do this is we are going to switch x and y. That's the other way of doing it. So the first step is to write this in x's and y's. So replace this f of x here with a y. So it would be y equals 3x minus 1. And then, so there's my original function. So now I'm going to flip-flop my x's and my y's. So this y becomes an x. This x becomes a y. So now here I have successfully, this is in fact the inverse. This is the inverse. Okay, but we want to write it in inverse fashion. In the inverse way, we want to write it as f inverse of x. So I'm going to need to get it down to a y equals. So now we just use our algebra. Let's add 1 to both sides and divide both sides by 3. So y equals x plus 1 divided by 3. Now let's write that as a function, f inverse of x equals x plus 1 all divided by 3. So if you notice, we get the same answer no matter which method we do it. Okay, so there's finding inverses in a nutshell. Okay, on to part 2.